supply associated with it, they can still readily divide because, remember from their pictures, they're really kind of small and kind of thin. Even the cuboidal ones are really kind of thin. They're going to be the tissue that divides the most rapidly. Mainly, they're interested in protecting things, secreting stuff, absorbing nutrients. So if you think it's epithelial tissue, on the test today, which on that third column, so first column is the numbers, right? Because you got to know which microscope you're using. The first column that you're going to fill in is going to be general category. The second column that you're going to fill in is going to be specifically what type of epithelial, what type of muscular, what type of connective is this, what type of nervous. The third category, or the third column, is either location or function. Now, not all of the time, but a lot of the time, epithelial tissue provides protection. So in a pinch, today and tomorrow on the quiz, if you can't remember what it is, but you think it's epithelial tissue, then I'd put protection down. Because it might be, you might get lucky and it might be worth some points. Yes, sir. Exactly, you don't have to give both, one or the other. You already know the kinds. We did a little bit of this on Friday. You've been cramming like crazy since last night at 9:30 or 10. Maybe you did a little on Saturday, I don't know. But at least since last night around 9:30 or 10. These are going to be, the simple squamous are going to be where you need protection, but you need things to flow through. You don't want to create some big barrier so that things, food and things can't flow through. So, air sacs. You want to protect the air sacs, but you don't want to make it so thick that the oxygen and the carbon dioxide have trouble going across. The blood vessels. You want to protect the inside of the blood vessels as things are being pushed through, but you don't want to cover them with something so thick that it's hard for the food, it's hard for the wastes to cross that barrier. Simple cuboidal, they're going to be the ducts of some glands. They can store stuff, right? You got the little squishy things, they're good for protection, good for things crossing. Cuboidal, you got some space in there. So you can actually have things like secretion products. What's even better for storing stuff are the simple columnar, because now they've got lots of space to store things that you could secrete. Sometimes they possess cilia, the little brooms on top. The nuclei are usually located along the base of the membrane. Now this one and pseudostratified columnar, which line the respiratory passages, they provide protection and they secrete stuff. Because if they're lining the respiratory passages, what do you know is in those respiratory passages? Mucus, right? What's the job of mucus other than to make you want to throw up when you hear someone go, and then, kind of hawk it up, right? Yeah, it captures things. So if you got bacteria floating around in there, if you got dust floating around in there, if you've ever been around a really dusty place, don't know how many of you grew up on farms and ever put up hay, but if it's really dry and you're putting up hay, and then you come in and you blow your nose and it's like all black and stuff from the dust that was out there, that's because the mucus that was secreted by these pseudostratified columnar cells has collected all that dust and kept it out of your lungs. If it gets in your lungs, then it can cause irritation. Irritation can cause the cells to skip the checkpoints in the cell cycle. If the checkpoints get skipped, then that could cause mutations not to be caught. If the mutations aren't caught, then that could lead to abnormal protein products that may lead to cancer eventually. That's actually how asbestos causes cancer. That's how black lung causes the tissues to die and sometimes causes cancer as well. It gets in there, it irritates, the particles irritate the lung cells. The cells are so worried about trying to get rid of that irritation, they skip the checkpoints. Same thing. Now instead of being one line, we've got multiple lines. If we really want a lot of protection, we need to stratify things. We need to make lots of layers. Because if you only have one layer and you rub it off, well, then you don't have any other layers that you can do things with. So if we really want to protect something, then we're going to stratify those layers. So it's our outer layer of skin, stratified squamous epithelial tissue, lines the oral cavity, lines the vagina, lines the anal canal. These are all areas where friction can occur. So if friction occurs, you don't want to just rub off that top layer of protection and then you're left unprotected, right? You want to have multiple layers to protect whatever is underneath. Stratified cuboidal. Again, we are providing now multiple layers of things so that we can secrete whatever it is we need to secrete. So you find stratified cuboidal cells in mammary glands. They would line the duct. They would be the cells that would help provide the secretion in among all of that beautiful and sexy adipose tissue. These cells would be the ones that would make and store the milk, the oils that then become what the babies need for nourishment. Stratified columnar. Part of the pharynx is made up of stratified columnar. The one that is found in the bladder and reminds me kind of a balloon. You could do this with a balloon. If you had a balloon and you blew it up just a little bit and drew some cell shapes on it that were kind of teardropped or kind of cuboidal in shape, and then you blew up that balloon, the shapes of those cells would change. So they would go from kind of a cubed shape to kind of a squamous looking shape because they would be pressed out. That's what happens to the cells in our bladder. So these transitional epithelial cells, whenever our bladder is empty, look more like the cubes. As our bladder gets fuller, then they get stretched out like cells on a balloon or like squares on a balloon. And then they would look a little more like columnar cells that are laid on their side, or they would look a little more like squamous epithelial tissue. So if you see cells that are kind of a mixture, epithelial tissue that's kind of a mixture of cuboidal and columnar, or cuboidal and squamous, you know you're looking at a transition. And bladder is really easy to remember for that one, because you got the balloon. We will come back to the gland part when we do chapter 6 later in the semester. So mark on this note